a tangent line intersects the circle, should say circle, exactly once. So this right here, tangent AB, is tangent to this circle. So other tangent lines would be right here, or here, or right here. Theorem 12.1 reads, if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So what that means is a tangent line has a perpendicular spot right here. That's called the point of tangency. Oops, that's not a good one right here. So you can use the fact that lines are tangent to answer questions. So if these two lines are tangent lines, by theorem 12.1, these have to make 90-degree angles. So you can figure out what angle X is because this shape is a quadrilateral. Remember, quadrilaterals add up to 360 degrees. So if I write 90 right here and 90 right here, I can figure out what X is. So in this case, X has to be 63 degrees. Same with this shape. You have this. If I know that DE is tangent, then this makes a 90-degree angle, and now you have this triangle. So this one has to be 52 degrees because this makes a triangle. Okay, then find the distance between the two centers of the pulleys. So the two centers, here are the two centers. So we're going to find the distance between here and here. Draw a straight line. So what we have here is we have this quadrilateral. And so far there's nothing that can help us calculate this. We're going to need a triangle. So what I'm going to do to make this triangle is make a segment that is parallel to the 35-inch segment. So that means that this is to be 35 inches. And right here has to be the 90, because if these two lines are parallel, these two need to be 90 degrees by corresponding angles. So right here, I'm going to draw this triangle better. So this is 35, and this represents the blue line. So we're trying to find that blue distance. So I need this red distance. So if I know that this segment's 14 inches and this segment's 8 inches, that means that this segment right here has to be 6 inches. So to figure out this blue distance, I'm going to use the Pythagorean theorem. So it's going to be 6 squared plus 35 squared equals c squared. So this is opposite of the 90, so it's c. It's kind of hard to see that it's a right triangle right here, but opposite of the 90 is the hypotenuse. So then you can calculate this out and find what c is. So just make sure that you draw a picture and draw a line that's parallel to the tangent line. And down here, is this segment a tangent? So remember, if it's going to be tangent, it means that this has to be a 90-degree angle. So if this is 90 degrees, it means that this has to be a right triangle. So we can check to see if this segment is if this triangle is right by seeing if the Pythagorean theorem holds true. So does 7 squared plus 24 squared equal 25 squared? When you calculate this, does this work? And the answer is yes. So therefore, yes, triangle NLM is a right triangle. Therefore, ML is perpendicular to NL. Oops, wrote this. ML, the segment, is perpendicular to NL, and therefore ML is a tangent, because for it to be a tangent, this would have to make a 90-degree angle. Here's another theorem. Two segments tangent to a circle form or point outside the circle are congruent. So if starting from segment B, if this is tangent and this is tangent, then we know that these two segments have to be equal. So we're going to use that down here to find the perimeter. So given that these segments are all tangents, so that means that this segment is equal to this segment is equal to this segment, and this segment is equal to this segment. So now I'm going to go in and fill in the missing one. 15 centimeters, 8 centimeters, 10 centimeters. So now if I'm trying to find the perimeter, I'm going to add up all the sides. So I'm going to shade the ones so I don't miss them. 10 plus 8 plus 8 plus 15 plus 15 plus 10. So we add that up and that's going to be my perimeter. So I have 20 plus 30 is 50, so it's 66 centimeters. So for this one, I know that this has to be 17, and this has to be 15, and I'm missing some information, so I can't do anything else. So sometimes you're given problems like that you know what the perimeter is, and you have to find this distance. But I can't do anything else with this one.